Okay, so now that we know how to calculate determinants, we can finally go on into probably the most interesting part of out of chapter 4 and 5, which is the matrix inversion method. So basically, remember we've talked about an inverse of a matrix in the last lecture, which is basically if we have matrix A and we pre-multiply or post-multiply it with its inverse, we are going to get an identity matrix. So basically, if you're thinking of numbers, you have 5 and you multiply it with 1 by 5, either pre-multiply or post-multiply, what you are going to get is 1. That is effectively what we are trying to do with matrices. We have 5. We want to multiply something with this 5 so that we get an 1. So likewise, we have A, and we want to multiply something with A so that we get an I. That's what we're trying to do. And so that is called inverting a matrix, from going from A to A inverse, A to A inverse. So matrix inversion is a 6-step process. Now, here is what you need to remember, and this is very important that you remember this, is that the difficulty in inverting a matrix is remembering the 6 steps and doing them in proper order. Each individual step is very easy. I'm going to go step by step, and you are going to see that this is very easy maths. 5 years ago, when you were, what, 15 or 16-year-old, you would have been able to solve each of the steps. It is very easy. Where most of the mistake in matrix inversion comes from during quizzes or exams is that people forget the steps. So all you have to remember is the steps. So I'm going to write down the steps now. So the first step is a squareness check. I mean, remember we've learned in the last lecture is that only square matrices have inverse. So the first step is to check that the matrix is square. Very easy. Second step is to check for something called non-singularity. Sounds complex, it is not. All this means is that determinant is not equal to 0. So we've calculated determinant of C, of B, of A. In each case, the value of the determinant was not 0. If the value of determinant is not 0, it means that we have a non-singular matrix, which is what we want. However, if the determinant is 0, that means we have a singular matrix, and that matrix do not have an inverse. Okay, so once we have checked for singularity, what we have to do is calculate something called a minor matrix. We haven't discussed this yet. We will come to this. After this, from minor matrix, we calculate something called cofactor matrix. Okay. Then number 5, we calculate adjoint of the matrix. And finally, we invert the matrix. Okay, so a lot of big names, big words, confusing words you may have not heard before. But as I told you, individual steps are very easy. For example, you guys already know how to do step 1 and step 2. And you can see how easy step 1 and 2 are. 3, 4, 5, 6, similar. Okay, so we are going to get started with a 2 by 2 case.